let me in the door. So I'm Dr. Pam Breyer. I'm the agrochemical toxicologist with the Agency of Agriculture, Food and Markets. Prior to this role, where I've been for about 2 years, a little over 2 years, I was the pesticides toxicologist for the state of Maine for 6 years. And then other relevant things would kind of fall under, I was briefly a professor of environmental toxicology in the biology department at Lamar University in Texas.
I can't. Lamar,
Am I too quiet?
I'm having a little trouble here.
I am quiet, so I will try to speak up. My apologies.
What's your academic work?
Lamar University. It's a regional college in Texas, so lower tier, but still 15,000 students. Different than New England universities. I'm from New Hampshire. I should disclose that when I'm first. So can I just launch in?
Yeah, and just, you're probably aware, we've had some testimony yesterday from ANR, from Matt Chapman. And then early in the day, we heard from, I'm already forgetting who it was, but we have taken a guest from our ledge council who gave us some background on Vermont, the existing Vermont statute that's been enacted over the past couple of years on PFAS.
Good. Because that's not my area. I did listen to the testimony from the Environmental Working Group when it came up on the, we got the email about that. And so part of what I'm talking about today was hopefully aimed at answering some questions that I heard from the group. And when Terry asked how much time I needed today, I said all day. Like, if I could, I'd lock the door and we would just have a good time talking about PFAS and pesticides, because I feel for the group. I was in my role as a pesticides toxicologist when PFAS hit the discipline, right? And it kind of threw us all back, and it was a huge learning curve. This is just not an easy 1 hour thing. This slides that I have today, I've taken out of a presentation I do for the pesticide applicator continuing education. And I've pared down as much as I can. I want you to ask me questions. I don't think we'll get through it all, which is why I put my summary slide first. And I'm just going to hit those points before we step into details. So the jargon I have up there, the 1FFC, that's my nomenclature for the one fully fluorinated carbon definition.
One fluorinated.
One fully fluorinated carbon. And that is in portions of Vermont law what Vermont has used, although there's in water, it's a little bit different than that. And this is the definition that is being promoted by the scientific community. And it's a helpful guide in the conversation. It's brought us all here today, right? Like, this is why we're talking about it, because there's this controversial definition. But in pesticides, we regulate by the individual chemical. We don't generalize about chemicals. We go chemical by chemical. And so when you take this definition and you move it into the pesticide regulatory world, we want to see each chemical in its unique risk evaluated. And I think it's pretty obvious that if you have 7 million of a thing, they're probably not all the same. And I have some pictures of PFAS that back this up.
Representative Bryan.
Yesterday, we heard they were 15,000.
I've got a
Now we're up to 7 million. So where is this going to end?
There was a paper that I referenced later that's 25 million. So the reality is there's about 1,200 PFAS in use, 800 to, did I say 12,000? 800 to 1,200 that are in common commercial use. But the definition, as I'm going to point to, is like, it's meant to get everything industry could ever use ever again, never again. That's the theme that they're going for. So as long as you can imagine a structure, they're going to keep putting it on this list. There's a database you can go to that the government has where you can get a list. And I've got those numbers, because that's one of the other numbers you hear when we're talking about how many chemicals are included. There are no mystery ingredients in pesticide products. I have a couple slides on this, but if it's in a pesticide product, somebody somewhere knows what it is, and that's information that we can get. the harmful PFAS are not allowed in pesticides. It's a violation of a pesticide registration for there to be these harmful PFAS in the products. And you can see now I'm using the word harmful PFAS because we've got multiple definitions at play. And so I'm going to get to what I mean when I mean harmful. Sometimes I call them the old-fashioned PFAS, but those ones that we are concerned about are not allowed in pesticides. Coming in from pesticides, one of the things that hampers the conversation is like the terrible track record and history of pesticide regulation in the past. But we are regulators of the federal and state laws. And so we live in what is legal right now. And so while there are studies out there that did show that people were trying to use fluorinated surfactants in pesticides, currently there are no fluorinated surfactants in pesticides.
Surfactants.
It's one of the ingredients that can be added to a pesticide that helps it spread out. So surfactants are also used in cleaning products. And that's one of the reasons that PFAS are used commonly. They're in many of our floor cleaning products as a surfactant.
Not an active ingredient, is that?
And you're using active ingredients. So we're going to talk about active ingredients that are PFAS and inert ingredients that fit that definition.
Representative O'Brien.
I just wondered about the harmful PFAS are not allowed in pesticides. So we talked a bunch about yesterday about intentionally added PFAS to various products. But there's a whole sort of universe of unintentional PFAS and even ones that are very hard to detect, depending on the chains breaking down.
Yeah.
So could any of those either through coming off, say, packaging or perhaps breaking down of non-harmful PFAS, could they turn into, even undetected, potentially harmful ones?
You're making me go out of order, but I appreciate it. The idea, if you're a manufacturer and you want a pesticide to be used in the United States, you go to EPA with a list, and it lists your active ingredients, your inert ingredients, and any contaminants that are commonly found in that product. After that point, your product cannot be found containing anything other than what you have specifically disclosed to EPA. And I have some federal citations that kind of back that up. So there was a huge debacle with fluorinated containers when that first came out. And that was one of the major, nobody in our industry understood that. I think there probably were scientists, material scientists somewhere that understood that that was happening. We've been fluorinating containers since the 90s. So that's not new. But nobody in our industry understood that. It was found first in pesticides because of a motivated citizen, which is wonderful that we now know about this. And I'm going to make the bold claim that we know more about pesticides than we do other chemicals. So you're talking about what's in a product. We have the authority to test a pesticide product for those ingredients. It's not technically possible for most of the formulas and PFAS that are out there, but that's something the federal government and the state has the authority to do to make sure that that kind of contamination does not occur. So the two definitions that it seemed like the group was talking about the most was the OECD definition and the EPA's TSCA definition. So that's the Toxic Substances Control Act. That's Matt Chapman's world. We don't do anything with TSCA in our agency. The OECD definition kind of is the definition that prompted this conversation a couple of years ago. One of the things that I guess gets underrepresented is that EPA was at the table in part of that OECD definition. The OECD is an organization that helps trade between nations. So if you do a test here, we know what it is so that trade can happen, right? That's the purpose of this definition. So we're all having the same conversation. I brought for you the document and it unstapled itself. I didn't send it to Patricia, but I can send it as an electronic version. It's 45 pages, so I didn't know. I was going to make one for each of you. There's some really important language in this document about what the OECD PFAS definition means. They say we are trying to make a definition that anybody could look at a structure and go, that's a PFAS. But they also say you can't base all of your decisions on that structure. The structure, there are now with this broad definition, there are gases that are PFAS. There are really tiny molecules. There are things that can get in plants, and it's really far away from the long chain PFAS that we know cause harm. So that language is in here for you.
Just the 12,000 that you are noting for EPA's definition. And I think that yesterday, did we hear it was 1,200 from the Ledge Council?
I can give you the link. There's a wonderful doc.
15,000 total, but 1,200.
The EPA test for 1,500 or
1,500.
Yeah, so anyway,
Yeah.
it's still many orders of magnitude possibly different, given that now we're looking at 25 million, but yesterday we were thinking 1,200 versus 15,000 was the distinction.
Okay, that's good to know. I didn't listen to any of that testimony, and I can go back. So this number comes from the CompTox dashboard, which is an EPA tool that is just a chemical list service. And this is the last time I checked, their TSCA list. I have it downloaded, and I can send you the Excel file with the different chemicals also. So, but that's part of the problem. And I think, just to be philosophical for a moment, that the conversation about the definition wastes all of our time. Like, we need to take action on PFAS, but we're talking about a definition, right? Like, we know that there's a small number of PFAS that are being used, and rapid action on those PFAS would be glorious. And then we could sort out the other definitions also. This is, I think that nobody is benefiting from this conversation. And it's not new, right? Like, so this group of chemicals has had multiple names over time. We used to call them PFCs in the aughts. And now we've got PFAS, and now we've got different kinds of PFAS. And it's unfortunate. I'll get off my soapbox. When I use the word PFAS, and I'm saying PFAS, we need to take action on PFAS, I'm really thinking about this older definition, this Buck et al. 2011 definition. There are about 300 or 400 chemicals in that group, and they look largely the same. And we're going to talk about chemical structure, and it's the chemical structure that drives the effect. And so when you have a group with a similar chemical structure, you can predict the effects. But when you have a group with a diversity of structures, you now cannot predict reliably what that group is. And it muddies the conversation. Yeah.
Sorry, this may be getting ahead also. But what is it about, say, like the 5 or 6 that we identified from North Bennington's water? What is it about those long chains that make them harmful, as you say, where so many others we either could say they're not harmful or we're unsure about?
I took that slide out for the interest of time. And I'm not a human health toxicologist. So Andrea Kirk, the state toxicologist, she's actually done research on PFAS, and she would be a good person for human health effects. But one of the things that my slide did show is when you have that long chain with carbon, 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 and all the fluorines, and then a polar head group, it looks a lot like a fatty acid. So fatty acids build the cells in your body. They are the energy mechanism in your body. And so that conformation allows it to get in the body and muck things up. And I don't want to simplify it. It's not the only reason. But if you look at the cardiovascular effects, the lipid effects, the liver effects, it kind of fits with a fatty acid profile, in where the dominant effects of known harm are associated with obstruction. The OECD definition, I'm going to read it. Try not to read my slides. But it's one fully fluorinated methyl or methylene carbon atom without any hydrogen, chlorine, bromine, or iodine atoms attached to it. That definition is clear. What has happened is in other states, they have used a less clear definition. And so I was in Maine when this definition came in. In Minnesota and Maine have the same exact definition. So I copied this from the Minnesota webpage. They took the definition where it said one fully fluorinated methylene carbon, and just said at least one fully fluorinated carbon atom. And I have a slide that shows from a chemicals perspective where that has introduced ambiguity into the regulation because it's being interpreted differently by different states. The EPA's definition, now over here I have OPP, so I apologize. This is Office of Pesticide Programs. They're part of OPPT, Office of Pollution Prevention and Toxics. And they are using the TSCA, the TSCA definition. And it's an ugly definition, right? It's got these various steps to it. But in essence, you can think of the EPA definition as requiring two carbons to be involved, but they don't have to be attached. They just need to be adjacent to one another. And I have some example structures that will show you what that looks like. And we've kind of, I just want to reiterate the point. The reason we're having this conversation is the two structures on the left. These are the long chain, that's PFOA and PFOS underneath it. Those were withdrawn from the US marketplace 20 years ago. And industry substituted the one on the right, that's GenX. It's like the same number of carbons. It's almost the same number of fluorines. It's very highly similar and can transition into a different terminal PFAS. It also has health effects, a little less, and it also persists for a really long time. And so this is like the scientific community basically saying, industry, no, we're not having this conversation again. We're not making this, we're not going down this path again because GenX is still highly toxic.
GenX is one of the 5 or 6 that water now tests for.
I am not good on Vermont law.
Okay, all right. We can double check that. I think it is, but
It looked like the last one that was added. Yeah.
This is a table out of a federal risk assessment. It's about 15 years old now. But one of the things it does show you is each of the columns, that's a different PFAS. And these are all highly similar in their structure. And even with this group where you're talking like 7 to 10 carbon lengths on these long chains that you have, and each row is a different effect seen in the human population. So you can see like they all have cardiovascular effects. Almost all of them have hepatic liver effects. So, and immunological kind of farther down, there's a lot of similarities in here. But at the same time, there are differences. And so my point with this slide is really that this precise structure matters for the precise effects that you're going to see. And these are some of them, right? So PFOA and PFOS are on the left-hand side. And these are the chemicals when I say old-fashioned or harmful, like these are the ones with documented health effects because of their structure. So the new definition that's being floated about, the one with the one fully fluorinated carbon or the OECD type definition. This is how I have 2 zoology degrees before my environmental talks. So I've taken years of chemistry, but this is how I think about this. You've got this molecule and it doesn't matter. It's this blob. It doesn't matter what it looks like, but as long as it has one carbon that comes off of it, and that carbon, all of the bonds that is not back to the molecule are fluorine, this qualifies you as a one fully fluorinated carbon molecule. So this meets that OECD definition. This would be PFAS in Minnesota and Maine, portions of Vermont statute, but not by the EPA. And so that's one of the chasms we're going to talk about. There are 6 PFAS pesticides according to EPA. There are 56 PFAS pesticides according to the state of Maine, and there are 93 PFAS pesticides according to the state of Minnesota.
How many according to the EPA?
6.
6.
6 active ingredients with about 50 products in the state of Vermont.
Representative O'Brien?
Just chemistry question. So could that be H2O? And in water, does it hook on to H2O molecules?
I don't know chemistry.
I don't know.
It does it for the sake of the definition, if you can make it stick. And this is actually part of that 25 million, right? Like if theoretically, if that molecule can hold together, people are putting it on the list of PFAS.
Just like the molecule.
Has to link to at least something. This definition has pulled in all sorts of veterinary medicines, human medicines, and pesticide active ingredients. So on the far left, you have Prozac, antidepressant that's been used by millions of people for 30 plus years. This is now considered to be PFAS under this one fully fluorinated carbon definition. On the far right, you've got a anti-cancer drug. And so part of my reason for including that is like when we talk about PFAS and we say PFAS cause cancer, and definitely some PFAS are linked to cancer, we also have to be inclusive of the fact that there's anti-cancer drugs in that broader definition. This is Procelicor, that's the brand name. It's fluoroperoxyfen benzyl. This is an aquatic herbicide. This is the only aquatic herbicide that ANR has allowed for use in the state of Vermont for the last 6 years because it has the lowest risk profile of aquatic herbicides. This is contentious now. Minnesota classifies this as a PFAS. Their definition is different, and they're interpreting one fully fluorinated carbon to mean a carbon that has at least one fluorine, basically, as long as the other bonds are not hydrogen. So in Minnesota, this is slated to be prohibited. The state of Maine, this is not considered to be PFAS. And so that's one of my, like, if you move forward with language, precise language would be lovely. It would be lovely to clarify that. Because I don't, honestly, like, you all are the managers, the risk managers. I work with the laws that you create, right? Like, that's you guys get to choose that one. So here are some pesticides that are PFAS by definition. And the point of this slide is that you can't predict anything about the pesticide based on it being a PFAS now. So at the far left, you have an herbicide. The second one in bromethalin. There was a question last week about rodenticides. Bromethalin is the alternative to the anticoagulant rodenticides that's commonly used. There's others, but it is one of the primary ones we see in the marketplace. Bifenthrin is a tick and mosquito insecticide. It's commonly used in backyards product and in agriculture also. On the far right, we have fipronil. Fipronil is it's an insecticide. It's used in agriculture, but it's also used on pets. Specifically, it's one of those like spot-on treatments for dogs. So there are some of the veterinary medicines that are considered to be pesticides and some are medicines, but fipronil fits in the pesticide realm. In the state of Maine, these are the active ingredients that would be considered to be PFAS. And I didn't pull in the list. Minnesota has actually a wonderful webpage that also has their active ingredients listed. And I'm not going to go through this, but it's easy to produce this list. We've done it. I just didn't do it for this presentation. So I apologize if you want that. I can do that for you guys.
Those were active ingredients?
Yeah. Yep.
Time to look, but are any of those like Prozac?
No, this is just the pesticides,
This is, okay.
just pesticides.
Sorry.
No. Okay, so one of the things about pesticides is that we look at them at the individual level. And I'm not going to step you through everything that's collected for a pesticide, but this is one snapshot to open the view into what information is collected about pesticides. So at the bottom, you can see this, it's covered, isocycloserum. This is one of the new PFAS pesticides that was approved by the EPA in December, this past winter. And I have 3 pages of this one table, and this is the ecological risk assessment. And it's just, see, do you guys see my pointer when I move? I don't see my pointer.
Oh, I see it now. It's in the upland game section.
So I'm going to try to do this really quickly. Examples of tests that are required for isocycloserum to go to market as part of their ecological risk assessment. You have an avian acute oral in 2 different species. So you had a passerine and a waterfowl. Was it required by EPA? These were both required. This next column says this was complete. And over here with the classification, you can see how EPA evaluated it. It wasn't 100% exactly what they wanted, but they also say that no additional data are needed at that time. And then avian subacute, so this is dietary exposure. Again, it's going to be in 2 different species. Yeah,
How do you, how do you assess this? I mean, I'm sort of envisioning Frankenstein's laboratory and they're poisoning all these different animals to see how they react.
yeah, about 15,000 individual animals will be used in every single pesticide registration. So usually the company doesn't have like a birdhouse, a fish house, a daphnid house, you know, like often this goes to outside laboratories. And actually you see that 810.2100. If you go to Google and type in EPA, oh, I'm sorry, 850.2100, you can come up with the test, the specific test that is being called for, and it will tell you the number of species, how long it should last, and all the other requirements for that test. And I have a link in this presentation to the EPA page. The reproductive test here would require lifelong exposure to the pesticide. So the bird would be exposed every single day of its life in order to look at the parameters of reproduction. And that's in 2 different species that was submitted. Sometimes EPA waives or the test is not triggered. So in mammals, so it looks like they didn't do any mammal testing, but that's actually a different several 100-page document that I didn't include. So all of the human health effects is in the human health risk assessment. And this is a document, the ecological risk assessment document. So there is a bunch of mammalian testing that's done, but there was no wild mammal testing required for this specific active ingredient. So then we have aquatic invertebrates, acute tests. We have oysters, shrimps, were also required and they were submitted. Down at the bottom, we have aquatic fish acute testing, and you have a warm water species and a cold water species. And you also have a saltwater species. Those are all acute tests. And aquatic invertebrates, we had daphnids and mysids, water fleas and shrimps. And then with the fishes, we have early life stage, both freshwater and marine. We have the full life cycle, freshwater, but not marine. And there's little footnotes as to why. So this continues. My point is that each pesticide has this level of detail put into its registration. We do not do that with chemicals in the marketplace. Like when the janitor comes through and buffs your table, those chemicals do not get this type of review before they get, by the nature of TSCA, they don't get this level of review.
Dawson.
Yeah. So Scott Yard didn't get this review.
No.
The treatments and the cushions and the
No.
rugs, Vortex.
So I went once, I picked a random chemical and I went to TSCA and looked at the documents that it pulled up. And there was a single acute study. And then there was modeling that was doing some basic like, well, this chemical fits into this group and we're not too worried about it. So that is the end of that. That was the end of that conversation.
So this is, our pesticides are highly, highly regulated.
It takes about 10 years, the 15,000 species, individuals.
And how many millions of dollars?
Well, I don't know if I'm going to trust industry on that one. Lots, right? Takes a long time.
Representative O'Brien.
But what we know, say about neonicotinoids now, be interesting to look at this
Yeah.
same original chart because it might be
Yeah, and
not
actually,
accurate anymore.
the next part, I'm going to skip over aquatic invertebrates, the terrestrial invertebrate toxicity. At the bottom 2 rows, you have adult acute contact for honeybees, and then you have adult acute oral exposure for honeybees. And then the rest of this table, because this is an insecticide, it's expected to be highly toxic to bees. These are all different types of tests for bees that were done. And you're right, the neonics were passed in the 90s. And so it was just a different standard. And that's part of what I'm saying, like what is regulated today and how it looks today is the world that I work in. And it's new, I guess. We're learning from our mistakes as a species on the planet. So there were some field studies, the large scale studies that are really important for understanding long-term effects in bees that were also done. This is what that molecule looks like. You can see it's actually got 4 fluorines, but it's got that 1 carbon with 3 fluorines. Yep. This is the webpage that you would go to if you are interested in what is required. So my kind of personal interest in this is in the environmental fate and transport of pesticides. So the 835 series tests are really, that's where my interest lies. But it lays out the rules for how a manufacturer reports to EPA. What do they have to report to EPA? What is the framework for that? And
Right.
Just quickly, does the EPA ever, revisit pesticides? Like we've been working on paraquat, so, it was okay in what, 1960 or something like that. Do they, now with what you were just saying, they're much more rigorous testing. Would they tell the industry to go back and
Yes.
do our present?
The volatilization study that you're waiting for from EPA is a product every 15 years. Pesticide has to be renewed. And if there is question, that's where they do a data call in and they say, okay, you've got time. You have a couple years, give us some more data because we have concerns.
Representative Nelson.
Yeah, and off script, but following Representative O'Brien on paraquat with the volatilization study being ordered. And Syngenta, who's one of the big 3 pulling their license in this country. If the other, I think there's 24 purveyors of paraquat besides Syngenta, small companies. If they don't pick up that study and do the volatilization study, what happens?
That's actually a good question. If there's a term, I don't know if that data call-in is automatically going to trigger the cancelization. Is that a word? I don't know if it automatically triggers them to cancel. But basically, in most of the scenarios when there's not data, EPA uses a conservative model. And one of the examples is like if the manufacturer doesn't give you the actual concentration that gets across the skin, they assume 100% gets across the skin. And so I'm assuming that they would rework with the worst case scenario. But we can look up that answer because it is written somewhere in FIPRA what would happen in that scenario. One of the questions that I often have heard, what would happen if you took the PFAS part off of the chemical? What would that look like? And that's like kind of an impossible question, but we have a really close answer with this. So these 2, cyhalothrin and cypermethrin, those are both pyrethroid insecticides. It's a class of about 20, 25 chemicals. And cyhalothrin, you can see, substitutes a chlorine for that fully fluorinated carbon. And so I wanted to step through a few parameters, and this is not a full risk assessment, but often when I'm asked to give a quick opinion on a chemical, these are some of the things that I'll look at to understand how does it move through the environment, what is its toxicity. So one is fluorinated, right? The one on the left is fluorinated. They have about the same solubility. Solubility is important because that predicts how likely it is to get into your water. The more soluble, the more of a hazard it is to water. So those are about the same. The KOW, that's a partitioning coefficient that shows how likely it is to get into fatty tissue. So you think about DDT in the environment. The concern was that it had the ability to get into fatty tissue. And here you can see that the cypermethrin is lower, and that's a better indicator. So green is good. The vapor pressure for cyhalothrin is lower, and they're both considered to be in the low category, but the lower the volatility, the less likely you're going to have inhalation exposures. The soil half-life, now there's a number of different half-life tests that are required, but I just chose like the field soil half-life. It is shorter. Oops, I went forward too many. It's only 22 days for cypermethrin and it is 60 days for cyhalothrin. So that might be the stability that you're looking for in the difference in these chemistries, right? Like the pyrethroids are based on pyrethrin, which is a naturally occurring chemical it's one of the organic insecticides, and it only lasts for a day in the field. So here with the cyhalothrin, you get it up to 57 days before the half-life. Oops, keeps going. Bioconcentration factor, they're both kind of in the same basic, we're getting up kind of high where we're concerned, but this means that it could accumulate in tissues, more so in the cyhalothrin, less so in the cypermethrin. The acute mammal LD50, cypermethrin is less toxic, which is interesting because the chronic mammal testing shows that cyhalothrin is less toxic. In fish, cypermethrin was more toxic. Now, all of the pyrethroids are very toxic to fish, and that's consistent with what you see here. And then with cancer, so EPA has 5 cancer ratings. It goes causes cancer, probably causes cancer, possibly causes cancer. There's not enough not enough evidence, and does not cause cancer. And cyhalothrin fits into that last category where they have enough evidence where they feel like it does not cause cancer.
Pyrethins are very detrimental to fly line too.
Fish.
I can imagine.
So the two, just want to be sure that we are understanding what we're looking at here. The one on the left is a PFAS by which definition?
State of Maine, state of Minnesota, portions of Vermont law. It's that one fully fluorinated carbon definition.
And it has a fully fluorinated carbon in pink or purple there. And on the right side, the molecule is the same, except that it's been that fully fluorinated has been replaced by something else.
Yeah. Yeah, so it's as close as we can get to saying why are manufacturers using it? How radically does it change? Because the whole thing, like PFAS are forever chemicals. And well, it's a pesticide, the pesticide product, and I can tell you how long it takes for that product to break down. And we'll get to what happens to the fluorinated moiety in the bit and what it becomes. Is that
Yes, thank you.
okay? We've talked about.
I just, sorry, while we're pausing, I just want to note the time.
Oh,
And
you want me to skip to fluorinated
no,
containers?
I don't want you to skip at all. I want to go back to your opening remark on how you would like to lock the door and spend the rest of the day talking about this. And we would like that too, but we've unfortunately scheduled other testimony for 10:30. So when we get to 10:30-ish, assuming we aren't done, and I'm gonna assume that we're not gonna be done, could we have you stop then and come back another time?
Yeah, so yeah, definitely ask more questions.
Yeah.
And I'll try to talk slower. If I'm coming back, we can,
Yeah, if you're willing to come back, we have plenty of time, even this week, I think, if your schedule allows, so.
so we talked about PFAS, pesticide, active ingredients. So the active ingredient is considered to be PFAS by definition. If you were to expand the definition to a 1 fully fluorinated carbon. One of the big misunderstandings is about the inerts. So, like I mentioned at the beginning, when a manufacturer goes to EPA to register a product, they have to tell EPA what is in the product. And you and I, well, you all, I actually probably could see it, but you all will never know what's in like in your off mosquito repellent or tick repellent. You'll never know what's in that. It's a trade secret. It's kind of like Coca-Cola, where the only way the manufacturer has to protect that is by keeping it a secret. However, it's not that nobody knows. EPA knows. About 10 different states collects that information also. You do have to have authority to collect that information, but manufacturers do work with folks in my position. So when the state toxicologist has a question, she can reach out to me and I will reach out to the manufacturer and ask for that. Now, they don't just like send you a document in the mail. They usually set up a secure web page that you can view and you can't download from like that. So that there's no mystery about what's in the products. But what you can do as a consumer is you can look at all of the possible ingredients. So this would be very similar to how FDA regulates the ingredients in Coca-Cola, right? Like, so you have natural flavors. Well, what's a natural flavor? You go to the CFR and you look up what is allowed as a natural flavor and what is not allowed. And it's the same thing with inerts. You go to this webpage and you can, They have made it more difficult. I'm not happy with the changes they've made on this webpage. But I think what it is they're moving to a new database. So you have to poke around, but you can download the chemicals that are allowed for use in pesticides. There's about 5,000 of them, and I can provide that to you if you're interested. So, and there's some weird stuff in there because, if you think about baits, right? So you've got like corn cob as milkway or spoiled egg solids. It's a long list. Not all of them are strictly chemicals.
Representative O'Brien?
Yeah, and is it similar to the pharmaceutical world too, where say, like glyphosate is a molecular, herbicide, but Roundup was the patented brand name, and eventually that patent runs out, and then Richard can use a cheaper version of glyphosate, right?
This accounts for so you've got glyphosate in probably hundreds of different pesticide products. And it's now out of patent, like you say. So there's about 10 different companies, I think, that make glyphosate. And what we're talking about here with the inerts is all the other random stuff that they put in. They can choose from this list of 5,000 chemicals to create the formula that they want. And with Roundup, because it's an herbicide, one of the things that's difficult is getting it through the waxy cuticle and into the plant. And so that's where some of these inerts come in handy because they can dissolve through those waxes. So you'll often hear that they're toxic. And there's actually, I think it's gone now, but EPA used to have a webpage just on the language of, do we call them inerts or do we call them others? And why is EPA flip-flopping on that language? At this point, EPA is like, we give up, call them what you want. You're going to be mad no matter what we call them. But the idea is that some of the inerts are going to be toxic to organisms. So one of the things you could imagine is acid. If you need your chemical at a certain pH, you're going to add an acid as an inert to that formula. That acid is toxic, right? Like it will just burn your flesh. So that's an example. There are others. But when the product goes for review, the reviewers look at all of the specific ingredients in each product, and they look for those kind of synergies. Industry will exploit any synergy it can. They're trying to get products that are more effective so that they are making them as effective and as lethal as possible. So that's the whole point here, is to be destructive to life. So you can find them. Minnesota has this really broad definition of PFAS, broader than the other states, broader than the OECD. They went through this list of inerts, the 5,000, and they looked for all of the inert ingredients allowed in pesticides that match their state's definition. And this is what they came up with. So we hear a lot about fluorosurfactant concerns in pesticides. And they have to be being used in pesticides because, like we mentioned, you need that surfactant action. But there doesn't seem to be good evidence for this. If you were to use a more conservative definition of PFAS, this would go down to about 4 different PFAS. And so I think that's kind of impressive. There was a paper that was published, probably 20 years ago in the state of Washington, and they were specifically testing adding a fluorosurfactant to a pesticide to see if it helped improve the efficacy of the pesticide. And it worked great. Different issue. So we know that there's been research. We know that there have been patents on getting these PFAS, these kind of traditional long chain surfactant type PFAS in pesticides. But today, when we look at the inert finder and we're looking for them, we do not see them in the inert finder. So EPA doesn't have a list of prohibited things. When EPA is done with a chemical, it just takes it off of this list. So there should be no long chain PFAS allowed in a pesticide product.
So when you said you think it's impressive, I'm not sure I understand what you think is impressive. You were saying that there were only 4.
Oh, so like out of 5,000 chemicals, and knowing that PFAS surfactants would help the efficacy of pesticides, we don't find them. That's they have not been allowed into pesticides. And I honestly can't tell you if they used to be allowed and have been removed by EPA. There was a pesticide that was a long chain PFAS looking pesticide. And when the ban of PFOA and PFOS came through the United States, it was removed from the marketplace. So at that time, there may have been fluorosurfactants in pesticides. I don't know. I can only look at the list today and tell you today, we don't see those long chain PFAS. And even using the most liberal PFAS definition, this is all you've got. And these tend to be very much like single fluorinated, or there's having 3 fluorine molecules on it. And here's an example. This is 1,1,1,2-tetrafluoroethane. And I include this to reinforce the idea that the broad definition brings in many different kinds of chemicals. This chemical it's a legacy that there's a list for. The National Organic Program uses the lists that EPA used to use. EPA doesn't use them for pesticide regulation anymore, but the National Organic Program does. So this is a list 4 chemical. List 4 chemicals are approved for use in organic products. So this is an example of a low risk product that was approved for use in organic pesticides because of its low risk status. It's a propellant. It's an inert, and it would be in there to help propel the insecticide or whatever it was.
It has one fully fluorinated.
Yeah, and this one, the fluorines are green. I've been showing you them in pink previously, but those are up there. So it's got 4 fluorines, and it's a tiny little molecule.
We should probably think about wrapping up, but I will let you decide when you're at a good place to stop.
Oh. Let me do this. This is like 4 slides on the same thing. There's no surprise ingredients. FIFRA, which you all are probably familiar with at this point, it mandates that the product contain explicitly what was approved when it was registered. And these are the federal citations. So it establishes it as unlawful for the composition to differ at the time of distribution or sale than what was disclosed at registration. It requires all impurities of toxicological significance to be reported and accepted at the time of registration. This is the lesson learned from Agent Orange. When 2,4,5-T was manufactured with dioxin as a contaminant, before there was an EPA, just for the record, this is what this prohibits, right? You can't have known contaminants of concern in a pesticide. EPA has stated in meetings, and they have it on their webpage with the link here, that EPA considers any level of PFAS to be toxicologically significant. And so that takes out any loophole of PFAS not qualifying. And then once the product hits the road, it's in distribution, registrants are required to report when there's impurity or when the composition differs from the time of registration. They're required to tell EPA, and they're required to tell EPA within 30 days. And that data, the person at EPA that we used to talk to the most on PFAS, so I'm on a national committee that liaises with EPA every 6 months. Our contact on pesticides, PFAS pesticides, retired. And so we haven't been able to get the insider information that we've been used to. And what I would like to know is what EPA has received since the fluorinated container issue came out for 6A2 reports where manufacturers are telling EPA this. I don't know of any. When I come back, I appreciate being let back also. I really do. We'll talk about fluorinated containers and the whole Anvil 1010 debacle and what that has started for the fluorinated container bit.
What was the name of the debacle? The Anvil?
The Anvil 1010 is the pesticide product that started the fluorinated container concern.
Right, well, that does seem like a good place to stop or to pause anyway. Yeah. And I'll ask Patricia, I've already asked Patricia if she'll check in with you, find another time sooner, I would say, rather than later. And if Steve, the other Steve, no, the other Steve.
Cool, Steve.
Able to join us on, at that time, then we'll welcome him as well. So thank you very much.
Yeah.
Very, very helpful conversation. And we will take a break. Let's take 10 minutes. And then we'll